Hello students, and welcome to the fourth video in a series of videos on rational equations. And in this particular video we're going to look at a problem with solutions, and this is chemistry solutions. So you have 225 milliliters of a 35% acid solution. How much pure acids needs to be added to have a 40% acid solution? So let me just show you some common approaches, and you can kind of decide for yourself some strengths and weaknesses here. So we can always set up this equation. This is something I see very often. I see, well, 0.35 over 225 ml is equal to 0.4 over x ml. Well, there's nothing particularly wrong just from looking at this, except we end up with this issue. What does X represent? Okay. Well, if X represents the acid that needs to be added, then you're comparing something that doesn't really make sense. You're comparing the total amount of solutions to so I have some choices here. The amount of total solution, the amount of current plus new acid, or just the amount of new acid. So you really, if you try to set up this way, you really have to think about what this variable represents and if this equation still works. Because this is, I'm guessing a lot of you just kind of jumped into this right away, and that's okay. And it may not be wrong. There may be a way to solve it this way and still get to the right answer. So don't be afraid to try this. But if you go this route, make sure you think about what this variable actually means and if it actually makes sense in your problem. If you can't reconcile it in your head, maybe another approach should be tried. Okay, so this is kind of the frustrating thing about solving word problems, because we always want like a neat solution that starts from point A and follows a straight path to point B, and sometimes that's possible. In the real world, there's just a lot of missteps, a lot of mistakes, a lot of frustration before we actually make a breakthrough. Okay. So I will show you, I'm going to hit pause here, and then I will show you the solution to this problem. Note that this method doesn't always work, and you kind of have to think about it with every different type of problem. So this will give you some ideas here that what I'm about to show you, but it's by no means a method that's going to work every single time. That's the beauty and the challenge of word problems. Okay. So I'm going to set up this, just go back to some basic principle here. I'm going to say that the total concentration of acid, let me switch up on marker here, is equal to the amount of acid over the total liquids, okay? Because the acids are part of the total liquids, and some fraction of that is going to make the concentration. Okay? So currently, this is our situation. We have a concentration of 0.35, 35%. Okay, that's given in the problem. This is one of our givens. Okay. The total amount of liquids is 225 milliliters. And we'll say the total amount of acid is A. So I can solve this, and I can get 0.35 times 225 is equal to A. Now let's look at what we want. We want the concentration to increase to 0.4, and we don't know what this thing is. We know it's at least 225, and we're going to have to add some stuff to it. and we know that we have at least 0.35 times 225, whatever that number is. Okay. And we're going to have to add some acid to this, so we need to add some pure acid to the solution. But when we add the pure acid, we are also adding to the total amount of liquids. So I'm going to make this variable called x, and I'm going to say that this is going to represent the amount of acid added. So I'm going to add some amount of acid to this, but remember that whatever I add to the amount of pure acid, I'm also adding to the amount of the total solution. Okay? And so now this is the equation that I can solve, and I'm going to solve this by multiplying both sides by the denominator. 0.4 times 225 plus x is equal to 0.35 times 225 plus x. And I'm just going to do some basic arithmetic here. So 0.4 times 225 is 90. And then 0.35 times 225 is 78.75 plus x. Oops, I forgot an x here. So there should be an x there. Okay. So I'm going to subtract 78.75 from both sides. And actually, at this point, this is probably the quote-unquote easy part of the problem, because this type of equation we know how to solve. Setting it up is, of course, a little bit more difficult. So now I'm subtracting 0.4x from both sides. It gives me 0.6x, and then I'm going to divide. And this gives me 18.75 is equal to x. And this is milliliters. And just to check, as always, we really need to check and make sure that this is true. So I'm going to use this original equation here. I'm going to say 0.35 times 225 plus 18.75 over 225 plus 18.75, because I'm assuming that's what x is supposed to be equal to. What does that all equal? Well, let's check. 0.35 times 225 plus 18.75. This is 97. I'm going to use a different color here. This is 97.5. And then on the bottom, you have 225 plus 18.75. This gives me 243.75. Let's divide those two. And that does in fact equal 0.4. Okay. So I'm going to go back to the point I made at the beginning of this video. There's other ways to do this. You're welcome to explore. You're encouraged to explore. Make sure that the solution, the approach that you tried really does make sense. And then make sure that the solution that you come up with at the end, or the solution that you solved for, when you substitute that into the original problem, it does make sense. Okay. So thank you for watching. And again, word problems, practical problems, always difficult. That's the beauty and the challenge of them. Only way to get better at them is to work at it, to struggle with it, and to get through those struggles, and then repeat again and again and again. And I assure you, you will improve, even if you improve slowly. There's nothing wrong with that. Again, thank you for watching. Have a wonderful day.